2012 Civil Engineering, question 46. A two-lane urban road with one-way traffic has a maximum capacity of 1800 vehicles per hour. Under the jam condition, the average length occupied by the vehicles is 5 meters. The speed versus density relationship is linear. For a traffic volume of 1000 vehicles per hour, the density needs to be found in vehicles per kilometer. The four options given are A 52, B 58, C 67 and D 75. The relevant NPTEL reference has been listed. So when we talk about the Green-Shields model in traffic flow theory, it basically indicates that the relationship between speed and density is linear. So if we assume speed to be on the y-axis and density to be on the x-axis, so the relationship between them will be of a straight line which looks like this. So at zero density, the speed will be maximum, which is called the free flow speed, and at zero speed, the density would be maximum, which is called the jam density. So here Vf is the free flow speed and Kj is the jam density in vehicles per kilometer, and free flow speed is measured in kilometers per hour. So at any point on this curve, speed and density are related by a linear relationship, which is given by V equals Vf 1 minus K over Kj. So we can see that when K will be equal to Kj, V will be equal to 0, and when K is equal to 0, V will be equal to Vf, that is the maximum speed. In this case, we have been given the length of a vehicle as 5 meters. So using this, Kj per lane would be equal to 1000 by LV, that is the number of vehicles in each kilometer, which would be 1000 divided by 5, that is 200 vehicles per kilometer per lane. So using this relation and the relationship from Green-Shields model, that is Qmax is equal to Vf into Kj over 4. So Qmax is given as 1800 for two lanes. So for one lane it would be 900 equals Vf into Kj, that would be 200 divided by 4. From this we would get the value of Vf as 18 kilometers per hour. From Green-Shields model we know that V is given by Vf into 1 minus K over Kj. Multiplying K on both sides, we would get Vk equals Vf into K minus Vf K square by Kj. So V into K would be equal to the flow in one lane, which would be equal to 500 equals Vf was obtained as 18 minus 18K square by Kj, that was obtained as 200. Solving this equation in a simplified form, it would give K square minus 200K plus 5554 equals 0, and the route would be 33.32 vehicles per kilometer per lane. So the density for both lanes would be equal to K dash, that is 2K, which will be 33.32 into 2, that would be around 66.67. This can be rounded off to 67. So the density in vehicles per kilometer was found out as 67, which is option C. The relevant NPTEL reference has been listed.